Chapter number 2, Introduction to SQL Tuning. After you have completed this lesson, you should be able to describe SQL tuning, summarize SQL tuning strategies, and describe Oracle SQL Developer. The first topic of this chapter, we're going to discuss what is SQL tuning, what is bad SQL, how we can try to understand the current issue, and how by collecting and analyzing data, verifying that the bad SQL is indeed a real problem. So SQL tuning is an iterative process of diagnosing and repairing SQL statements that fail to meet a performance standard. So an SQL statement can become a problem when it fails to perform according to a predetermined and measurable standard. A typical tuning session has one of the following goals. One goal can be to reduce the user response time, which means decreasing the time taken for a user to issue a statement and receive a response. Another goal can be to improve the throughput, which means using the least amount of resources necessary to process all rows accessed by a statement. Now, which are the two main phases in a typical SQL tuning session? Well, that's on one hand identifying the issue, and on the other hand, determining a cause. Now, the first step in the SQL tuning session is to recognize that an SQL statement is a bad SQL. You then need to define what is then the actual problem. Clarify the details of that issue. And then by means of collecting data and analyzing that collected data, verify that the issue is the problem. Now, once you have identified the issue, you need to determine the cause. You're going to check certain basics, which we will discuss later on in the chapter. And after checking those basics, you're going to choose an appropriate tuning strategy. Once you have chosen your strategy, follow the steps in that tuning strategy, choose a solution and implement it. And after the implementation of that solution, verify if the problem has been resolved. Now, one of the benefits of SQL is that you can write different SQL statements that produce the same result. Any SQL statement that produces the correct result is a correct SQL statement. However, keep in mind that different SQLs can require different amounts of resources. So bad SQLs, they can be correct, but bad SQL is inefficient because it uses more resources than necessary. Such bad SQL can be the result from a bad design, poor coding, or an inefficient execution plan. Symptoms of bad SQL can be any of the characteristics that is mentioned on the slides. Bad SQLs can show an excessive amount of parse time, or bad SQLs perform an excessive amount of IOs, or they show an excessive amount of time spent on the CPU, and or also showing an excessive amount of waits being experienced. Now, first of all, you need to try to understand the current issue. This is critical to finding the cause of and solution to the problem. So it might be possible that SQLs have turned into bad SQLs because of changes that might have happened within your database environment. Maybe the database got upgraded, or maybe new statistics, new optimizer statistics have been gathered, or maybe a schema change was implemented. Maybe an index was being created upon a table inside a schema, and maybe the wrong type of index has been chosen, leading to inefficient execution plans. Maybe somebody has changed parameters. We're going to see later on in this course that there are a lot of parameters that will influence the behavior of the optimizer, which is responsible for rendering the most optimal execution plan. Maybe the application has changed. Maybe the volume of data inside a table has changed. But the necessary new optimizer statistics have not yet been gathered. Or maybe changes have been implemented at the operating system and the hardware level. Now, you're going to gather data to verify that the performance problem originates inside the database. And there are several tools available to identify those bad SQL statements. Now, it's not the scope that we're going to discuss right now into detail all of the following tools mentioned on this slide. But for instance, you have the SQL monitoring tool, which is actually a package called DBMS SQL monitoring, via which you can in real time follow up an SQL statement, look into its execution statistics, looking into the execution plan that is currently being used. Also, you have the SQL Trace Facility, which is a basic performance diagnostic tool that helps you monitor and tune applications that are running against the Oracle database. Enables you to assess the efficiency of the SQL statements that an application runs and generate statistics for each statement. The trace file will then serve as input to the utility tkprof in order to generate a more human-readable output. You also have a tool like SQL Performance Analyzer, and this is a tool that you can use to assess the overall effect of a change, like a parameter change, on a full SQL workload. If you have the appropriate packs, you can have a look at the automatic workload repository, and such automatic workload repository reports include a set of top SQL listings. And each report will list the top SQL statements sorted by resource usage in several categories like elapsed time, CPU time, the number of gets, etc. You can also use tools like ADDM, the Automatic Database Diagnostic Monitor, that will analyze for you the performance data that is collected from the database instance. Also, you can rely on the Automatic SQL Tuning Advisor, which is an SQL tuning process, automated, that will identify problematic SQL statements. Also, you can use a tool like the SQL Test Case Builder, and this is a tool that will capture information such as the query being executed, the table and index definition, PL SQL packages and program units, optimize statistics, SQL plan baselines, etc. So that we can try to reenact the issue inside a test environment. You can also verify operating system statistics and general machine health checks before tuning the instance to verify that the problem is the database instance and not the machine itself. Now, does the performance issue originate in the operating system or in the instance, or is it really a bad SQL that is the real problem? This is a question that is not always easy to answer. So the first thing that you're going to do is you're going to collect data at the operating system level, or you're going to look into automatic workload repository reports, and you're going to try to find out if there is a shortage on resources. And it might be possible that out of that collected data, you might see a high CPU utilization. When you see this, you can then find out which processes on the operating system show a high utilization on the CPU time. And this can be Oracle processes. What you're going to do then is, for those processes, you can then start collecting data. You can start SQL monitoring. You can ask to generate a 146 trace file. Use tkprof to format those trace files into more human readable output. Now, if the statistics collected on the operating system do not show a resource shortage, Okay, but people are still complaining that, for instance, their SQL statement is slow or that it's taking a considerable amount of time to execute. Well, you then have the possibility to start collecting data for that particular session, or even start collecting at the instance level. You're going to use exactly the same tools like SQL monitoring or generating a 10.046 trace file. You can have then the possibility to look into, is it a problem at the SQL level? Is it an Oracle Net issue? Is it a bug problem? Is it maybe a misconfiguration of the database? And based upon that collected information, you're going to choose an appropriate tuning strategy. Now, the second topic that we're discussing within this lesson is the SQL tuning strategies. We're going to discuss things like sanity checks, what is advanced SQL tuning analysis, what is sparse time reduction, what is plan comparison, what is a quick solution strategy, and what is a query analysis strategy. Now, when choosing an SQL tuning strategy, like a quick solution strategy or a query analysis strategy, there are a couple of things that you need to do after you have identified the SQL problem. And this is important in your choice of the most efficient way to tune that SQL statement. Now, all of those bullets mentioned on this slide are explained in much more details in the subsequent slides. Now, first of all, checking the basics. That's always one of the first things that you need to check. First of all, make sure that the statistics, the optimizer statistics, that they are available and that they are up to date. Also check your parameter settings. Like I've already mentioned earlier, there are a lot of parameters that will influence the behavior of the optimizer when it needs to make decisions on which execution plan is being considered to be the most efficient. One of those parameters is making sure that the optimizer mode has been set correctly. Also, you have the possibility to instruct the optimizer to use specific indexes or to come up with specific execution plans by means of hints. Well, the inappropriate use of hints can lead to less flexible execution plans, can also lead to less efficient execution plans. Now, an advisor that you can also use within your database is your SQL Tuning Advisor. In order to be able to use the feature of the SQL Tuning Advisor, you must have the tuning pack option. Now, via the SQL Tuning Advisor, you can ask to analyze a specific SQL workload. And you can launch SQL Tuning Advisor manually yourself. And once you do so, it's going to check if the optimizer statistics are up to date. It's going to see that maybe by adding an index, we can come up with a much better execution plan. But the advice will be to run the Access Advisor, which is the expert on index utilization, partitioning, and materialized views. Also, the Tuning Advisor can give us recommendation to rewrite your SQL statement. It can also come up with an SQL profile, and an SQL profile are optimizer statistics for a specific SQL statement. Just as you have optimizer statistics for a particular table, a profile are optimizer statistics towards a particular SQL statement. Now, you can launch the SQL Tuning Advisor yourself. As of Oracle 11g, by default there is a nightly run of the SQL Tuning Advisor that will analyze the statistics for you, will perform SQL profiling, will analyze all the access parts like the utilization of an index, and also performs an analysis of the SQL structure. Now, if you have a good execution plan, you can use the execution plan comparison strategy to find where the good and the bad plans differ. That way you can modify the query to produce a good plan, or you can focus on a particular place where they differ and determine the cause for the difference. So you're going to compare the good and the bad plans, find the differences, try to fix the query by making a bad plan look like the good one. Now, of course, one of the prerequisites of this plan comparison strategy is how can we capture execution plans. This is something that is explained in a separate chapter inside this course. If you need to make the query perform well immediately and you're not interested in the underlying cause of the problem, you can use the quick solution strategy to give the optimizer more information and possibly obtain a better execution plan. The following is a strategy for a quick solution is that first you're going to check the basics. This is something that we have already discussed in one of the previous slides of this chapter, where you're going to check that the optimizer statistics, that they are available and up to date, and that also, for instance, you use the appropriate and valid hints. Once you have checked the basics, try to find a good plan and implement that new good plan. Now, what can you do to find a good plan? Now, first of all, if you have access to the tuning pack, you can use the SQL Tuning Advisor. Also, you can try to build up a good test case and see if you're going to change parameters like the optimizer mode or optimizer features enable parameter on how this would influence the decision making of the optimizer coming up with an execution plan. So you can try to leverage the optimizer by changing the settings to obtain a better plan. And this can be done within your own production database because the following parameters can be changed at the session level only. Now, first parameter is the optimizer mode. And if the optimizer mode is currently all rows, you can then use first rows n, where n reflects the number of rows that the user wants to see right away. If a particular query performed better in an older version, you can use the parameter optimizer features enable to roll back the optimizer to the older version. By the parameters optimizer index cost adjustments and optimizer index caching, you can tune the optimizer's behavior for access path selection to be more or less index friendly. That is, to make the optimizer more or less prone to selecting an index access path over a full table scan. You can also make use of dynamic statistics. By those statistics, it will sample the number of rows returned by the query and determine very accurate selectivity estimates that often lead to good execution plan. Also make sure that the appropriate and valid hints are being used. How are you going to implement that, the new good plan? Well, you can accept a profile from the SQL Tuning Advisor. You can use an SQL Tuning profile that was generated from another good plan, or you can also make use of SQL Plan Management. The technique chosen depends on the modifiability of the query or the application. Now, you can also choose the query analysis strategy, and you're going to use that strategy if a good plan is not readily available, when an urgent solution is not required. You really want to determine the underlying cause, making an SQL a bad SQL, and also you choose that strategy if the query may be modified. Now, this strategy will focus on statistics and parameters, how your statement, your SQL statement is being structured, also looking for inefficient ways of accessing data, so analyzing the data access paths, digging deeper into the join order and the join methods, and you're also going to look into unexpected operations such as parallelism or the lack of partition elimination. In the query analysis strategy, you're going to collect data for the query. You're going to try to collect the execution plans, collect information about the tables or the views that are being accessed by that query. Also, dig deeper into the object statistics and system statistics, which play a crucial role for the optimizer in determining the execution plan. Look if histograms are in place. Look up the settings of parameters that influence the behavior of that optimizer. Now, there are several tools to collect that specific data. You can use the SQL Tuning utility. You can use the package dbms stats. You can perform SQL tracing and use tkprof to produce more human readable output based upon the captured trace file. You can also launch pre-delivered script files like the StatSpec report SQL and the AWR SQL report scripts to collect information about captured queries. Then you're going to examine those SQL statements. So you're going to look at the query for common mistakes, like understand the volume that is being returned by that SQL statement. Also, if you're going to perform a join, make sure that there are no join conditions missing, because this will otherwise lead to cross products. Also look for unusual predicates. Maybe you're seeing where clauses or order by clauses that are maybe not necessary. Also look for constructs that are known to cause problems, such as large in-lists, outer joins, hierarchical queries, the utilization of views, inline views, and subqueries. After you have captured the execution plan, you're going to analyze that execution plan to find areas that need to be tuned. So examine data access paths, such as full table scan, or look if an index is present and if that index is being chosen as the most optimal way to obtain your data. Examine the join order and join types, such as the nested loop join, the hash join, and the sort merge join. Also review the actual number of rows returned and the estimated number of rows, and look in the execution plan for steps where there is a large difference between the actual and the estimated rows returned by the query. Also look for planned steps where cost and logical read differ significantly. Now, where can you find those execution plans? Well, you have several tools, like you can look up the execution plans that have been captured and placed inside the shared pool by accessing them via the views VDL or SQL plan. You can also look into execution plans that have been captured in AWR reports. You can generate an event 153 trace file, where you can also look into what is then the ultimate execution plan being chosen. You can perform SQL tracing. You can use pre-delivered scripts to find those execution plans. There is a separate chapter in this course where we're going to focus on the different techniques on how to capture those execution plans. Now, also in this query analysis strategy, you have to review some common observation and causes. Look at poorly written SQL statements. So maybe you have unusual predicates being used inside your SQL statement. Verify if an index is present and see if that index is being used or not being used by reviewing that execution plan. Also, if there is no index, an index can never be chosen, meaning that the execution plan for your query will always result in a full table scan. Also, whenever you're going to perform a join, so you perform a query upon two or more tables, make sure that the tables are being joined in the most optimal order. Also, for instance, avoid data type conversion, because if Oracle needs to perform a conversion, like converting the data type, this makes any index on the column of which the data type is being converted, makes the index unusable. Also look if certain transformation techniques are used or not being used, like predicate pushing view, merging, etc. These are all things that we're going to explain in much more detail in later chapters in this course. Determining the solutions for the bad SQL. Like I've already mentioned a couple of times, make sure that the optimized statistics are there and that they are up to date. Also, maybe an index can alleviate the problem of the bad SQL, or maybe there's an existing index that needs to be recreated, that needs to be coalesced or rebuilt. You can also use hints to force the optimizer into a certain direction when coming up with an execution plan. You can use dynamic statistics. You can try to eliminate implicit data type conversion because this will make indexes unusable at that moment in time for that query. Also, maybe try to rewrite your query to permit the use of an existing index. Now, the last topic of this chapter is an overview of the development environments. So the development environments that you're going to use throughout this course during the exercise is Oracle SQL Developer or Oracle SQL Plus. Now, Oracle SQL Developer is a free graphical tool that is designed to improve your productivity and simplify the development of everyday database tasks. You can easily create and maintain stored procedures, test SQL statements, and view optimizer plans. So you can perform tasks such as browsing and managing database objects, executing SQL statements and scripts, editing and debugging PL SQL statements, and creating reports. Via SQL Developer, you can connect to any target Oracle database schema by using standard Oracle database authentication. The other tool that you can use is Oracle SQL Plus, which is a command line interface that enables you to submit SQL statements and PL SQL blocks for execution and receive the results in an application or a command window. It ships with the database and is accessed by clicking an icon or from the command line. Now, to conclude this chapter, there are a couple of quizzes. And the first quiz talks about views. Now, although views provide clean programming interfaces, they should be used carefully because they can cause suboptimal, resource-intensive queries when nested too deeply. Is this true or false? Well, this is true, something that we will discuss in a later chapter. But if they are being used or nested too deeply, this can lead to suboptimal, resource-intensive queries. So the right answer is A. Now, the query analysis strategy is used when an urgent solution is required, if you want to determine an underlying cause, or when a good plan is available. The right answer is here B. You use that strategy if you want to determine the underlying cause. So in this chapter, you should have learned how to describe SQL tuning, explain SQL tuning strategies, and describe Oracle SQL Developer. The exercises of this chapter will cover the utilization of SQL Developer. Workshop 2 of the SQL Tuning for Developers course. In this workshop, you will perform tasks such as display an execution plan by using the explain plan command, display an execution plan by using the $v view, and analyze and fix the issue. The scripts that are needed for this workshop are mentioned here in the workshop guide. To make your life easy, already open those script files, which you will find under the workshops folder in your SQL Developer environment. So you can see here in my SQL Developer, via the workshops folder, I've opened setup02.sql by double clicking it. I've opened WS02 and all other script files needed for this workshop. So this workshop is to review the execution steps of an SQL statement section. You review the SQL statement that uses a bind variable in the index column. You also analyze two execution plans of the SQL statement using the explain plan command and the $view. After you have completed this workshop, you should be able to understand why the two execution plans are different for the same SQL statement. Now, the first thing that we will need to do is we will have to execute the script setup02.sql to set up the environment for this workshop. So in my SQL developer, I've opened setup02.sql. Make sure that you choose the HR connection and you're going to run the script. This script is going to create a table emp with 4 columns, and the emp ID column is the primary key column. Also, a couple of records are being inserted into that table emp coming from a select statement upon table employees, and also the table statistics, the optimizer table statistics upon table emp, as well as on the index, are being collected. Then what you need to do is you will have to execute the script ws02 to analyze the execution plan by using the explain plan command. So you're going to verify if for this select statement using a bind variable with bind variable value equals to 90, if the emp ID IDX index, which is the index of the primary key, if this is being used. And via the display function, you're going to display that execution plan. So here, I'm going to my SQL developer, WS02, HR connection, and I'm going to run the script. So what I'm seeing is that my bind variable emp ID is set to 190, and I say explain plan for this particular select statement, and then use the display function of the package dbms xplan to show the execution plan of the last explained statement. And what do I see is that indeed the optimizer says, when I've asked him to build up an execution plan via that explain plan command, he says, I think the most efficient way to carry out this select statement is by making use of that index. So yes, emp ID IDX has been used. Then what you're going to do is we're going to execute the SQL statement in WS02 again. So we're not going to ask to come up with an execution plan via the explain plan command, but we're actually going to execute that statement. Statement is the same, emp ID is 190, and then that statement plus its execution plan will be stored inside the cursor cache of the shared pool. And then what we can do is, via $SQL area, we can look up if indeed that statement is inside the cursor cache, pick up its SQL ID, and use that SQL ID to display the execution plan of that particular SQL statement. And that's the execution plan that has actually been used and cached inside the cursor cache of the shared pool. So what we need to do is, first of all, we're going to execute the statement in ws02.script file again. But in order to execute it, we're going to use the script w2s2_b.sql. So here, that's that script file, where I'm actually going to execute that particular select statement. Make sure that you choose the HR connection. You're going to execute this. You see the record being retrieved, and then looking into SQL error to see if that select statement is indeed inside the cursor cache of the shared pool, and I'm picking up that SQL ID. And then I want to show the execution plan that is cached inside the cursor cache for that particular select statement. So what you need to do is you will have to copy that value, and then you go to the script w2s2b1, where you're going to use the function display cursor to show the execution plan of that particular SQL ID. So what you need to do here is you will have to paste the SQL ID that you have found via the previous executed script file. You're going to paste this over here, and you're going to choose HR connection. I'm going to execute this. And what do I see is that he's not using the index, but that he's performing a full table scan. While when I did the explain plan command, he came up with an index scan, but when I'm executing it, he comes up with a full table scan. So I have two different execution plans. So we picked up the SQL ID. We use that SQL ID in the function display cursor to show the execution plan. And we have seen that when I execute the statement, that it's a full table scan and not the index range scan that was produced when I explained the statement. Now, why are the execution plans of the explain plan command and the execution plan of the actual execution, why are they different? Well, the explain plan command doesn't perform bind picking, so it's not going to have a look what is the value of that bind variable, and based upon that bind variable calculate selectivity and cardinality. In fact, when you execute the statement, like in task number 2, then you will have a look at what is the value of that bind variable and calculate, based upon that value, the selectivity as well as the cardinality. That's the reason why I see two different execution plans. Now, once you have done this, you're going to run the cleanup script so that you set up the environment for the next workshop. So I take cleanup 02, choose HR connection and execute this. So which statements are true about the explain plan? Well, only A is true. The explain plan command is used to generate an optimizer execution plan, but it will not execute the statement. And when a bind variable is used, the explain plan command peeks at the value of a bind variable is not true. So only A is true in this case. Now, what is the following step involved in this particular query execution using a bind variable? Well, parsing, then you have the bind phase, execute and fetch stage. Let's have a look at the exercises for lesson number 2, Introduction to SQL Tuning. This practice will cover the utilization of SQL Developer, and it's in this lesson that you will get acquainted with the SQL Developer functions. Before we can start the exercises, we need to make sure that our database has been started. How are you going to verify if the database has been started? And if not, how do we start up that database? This is the exercise of question number 1. Well, you go to your practice machine and there you're going to open your terminal. You're going to launch the SQL Plus executable. And you're going to ask to establish a connection SSDBer to your database. As you can see, I'm getting the message connected to an idle instance. This means that the database environment has not been started. And I can start it up by issuing the command startup. This will take a few seconds. Now, the database that we are starting is a container database composed of one or more pluggable databases. Now, once I'm seeing the message database opened, the database is open, but that does not mean necessarily that all the pluggable databases are open. Well, I can issue the command alter pluggable database all open to request to open all the pluggable databases. Once this is done, via the command show PDBs, you can then verify which are my pluggable databases. We only have one, which is the ORCL PDB pluggable database. And as you can see, which is open in read-write mode. So now our database is ready for the exercises as mentioned in the activity guide. The next question is that you're going to use SQL Developer, and in SQL Developer you're going to establish multiple connections. You're going to create a so-called SH connection where you connect to the ORCL PDB pluggable database as user SH with password SH. You will then also, if you scroll further, you will then also create a connection as user HR where you connect as user HR with password HR. You will set up a third connection as the OE user. You're going to call it the OE connection. And you're going to set up a fourth connection as the sys user. All connections connect to the same pluggable database, ORCL PDB. How are you going to set up those connections? Well, you go back to your practice machine. And on your practice machine, you're going to double click the SQL developer icon on the practice machine's desktop. This will start up SQL developer. As you can see that at this moment in time, I have no connections at all that have been created within my SQL developer. Well, how do you create your connection? Well, you select Oracle Connections, you click upon plus, and you will get here the window to create a new or to select a database connection. The first connection to be made is the SH connection. And via this connection, you're going to establish a connection as user SH with password SH. And to avoid that, I always have to type in the password for this connection when I'm establishing a connection. I can check the checkbox Save Password. The database that we're going to connect to as user SH when using this connection runs upon our local machine. We're going to contact the listener on port number 1521 and we're going to ask that listener to establish a connection as user SH to our pluggable database ORCL PDB. Before you're going to save this connection, you then have the possibility to first test out if all the connection details have been filled in correctly. And as you can see, the test has been successful. And then you have the possibility to save your connection. And you can see here that underneath Oracle Connections, I have a first connection called SH connection. But then in the activity guide, they're asking you to create a second connection as the user HR. Well, your new select database connection windows is still open. So what I'm going to do is I'm going to create a connection with the name HR_connection, via which I'm connecting as the user HR with password HR and establishing a connection to the same pluggable database. You have the possibility to test this out. You see that it is successful and you can save this and you see that I have now a second connection being established within my Oracle Connections view. Then I'm going to create my third connection, which is the OE connection. The username is OE, the password is OE. Still, we're connecting to the same pluggable database. We can test this out, it is successful, and we can save this. And you see here my third connection, OE connection, that has been created. And then in the activity guide, it's indicated that we have to create a fourth connection, which is called the sys connection, where we're going to connect as user sys. The password is Oracle_for you, as mentioned in the activity guide. But make sure that if you want to establish a connection as a sys user to that pluggable database ORCL PDB, you have to make sure that the sys user always connects as the sysdba user. Otherwise, you will get an error message. Once again, we can test this out. You see that I don't get any error message. It has been successful, this test. And then I'm going to save that connection. So you see that in total, 4 connections have been set up to the same pluggable database ORCL PDB. 1 connection as HR, 1 connection as OE, 1 connection as SH, and 1 connection as the sys user. You have then the possibility to simply cancel this window. Those connections have now been permanently created. If now I go back to the activity guide, the next exercise of this activity guide of chapter number 2 is to browse the structure of table employees within the HR schema. So you're going to look at the structure as well as look at the data inside that table employees of the HR schema. Well, what you do is it's very simple. You go back to your SQL developer and you're going to expand the HR connection. So you expand this. It's now logging in into the ORCL PDB pluggable database as user HR. Then I'm going to expand tables, and there I can see which tables exist within that HR schema. And then I click upon table employees, and you see that it opens a new tab in SQL Developer showing me the information about table employees. And the first tab being shown is the columns tab, showing me what are the columns of that table employees, its data type, is it nullable, what are the comments upon that column. You also then have the possibility to click upon the data tab, where you can then have a look at the rows that exist within that table employees that you have. So that is browsing the structure of the table employees in the HR schema and how to view the data inside that table employees of the HR schema. Now in SQL Developer, you have the possibility to run SQL as well as PL SQL statements. So what they're asking you right now is, as user HR, to carry out this select statement, where you're going to obtain all the employees that have a salary that is bigger than 10,000. To execute those select statements, you will have to open an SQL worksheet. Now, from the moment that you're going to open a connection, in this case as user HR, automatically an SQL worksheet for the HR connection is being opened. But you have the possibility to actually, via the pop-up menu in HR connection, you have the possibility to open an SQL worksheet. You also have the possibility to click here upon the icon to open an SQL worksheet. But as I've stated, from the moment that you're going to open a connection, automatically an SQL worksheet is going to be open. And then you're going to type in your SQL statement that you would like to execute. And in this case, they're asking you, can you, from table employees, show all the records where the salary is bigger than 10,000. Now you type in your command, now you want to execute it. Now what you can do is you have the possibility to click upon the button Run Statement or the key combination on your keyboard, Control Enter. This will execute the statement that currently has the focus. And if I execute this, I can see here in the query result window the result of, in this case, that select statement. You also have the possibility to run the script. Now, when you click upon Run Script, all the SQL commands that you have typed in the SQL worksheet will be executed, while the button Run Statement will only execute the statement that at that moment in time has the focus. Plus also, if you're going to run the script, in this case, it's only running one SQL statement, you also see that it's another output window where the data being retrieved is being shown. So here I've executed my select statements, I run the statements, but they also ask me to click upon the execute script icon or press the F5 key to run the script to execute all the commands that have been placed inside that SQL worksheet. Also via SQL Plus, as well as via SQL Developer, you can execute PL SQL. Now the next exercise is asking, can you please show on screen the message Hello World? You're going to do that by means of the package dbms output, which contains procedure and functions to show messages upon screen. Now, if you're going to call procedure and functions of that package dbms output to show message on screen, you have to make sure that set server output has been enabled. Otherwise, messages will not be shown upon screen. Now, how are you going to enable the server output in SQL Developer? Well, what you will need to do is, in SQL Developer, you go to View, and you click here upon DBMS Outputs. And you see that you get here a new window. And what you're going to do is you're going to click here upon the plus to enable DBMS output for a connection. And it's asking you, but for which connection would you like to enable it? For the HR, the OE, the SH, or the sys connection? Now we're going to enable it for the HR connection. And I click upon OK. And then I'm going to call procedure and functions of the package DBMS output to show messages upon screen. Now, what I'm going to do is I'm going to wipe out this select statement in my worksheet, or you can open a new worksheet if you want to. And I'm going to call the package DBMS output, which contains a procedure put line to show messages upon screen. And as stated in the activity guide, we're going to show the message hello world. And I also need my end block. Now, once you have written this PL SQL block to show a message upon screen, I'm going to run this statement. And as you can see that in the script output, the PL SQL procedure has been successfully completed, but the message that I'm showing is shown in this DBMS output view. So we have to enable DBMS output for, in this case, our HR connection. We enable it. And then we're going to call upon the procedure put line to show the message hello world upon our screen. Yeah, this is the output as I have shown you.